Hi, well, welcome everybody. Oh, there we go. Welcome everybody to Brighton Py. Well done for braving the strikes and getting out on a wintry night, although it's quite warm outside. But yeah, welcome. We've got loads of newcomers tonight, which is great. I hope you enjoy it, and loads of people that aren't so new, and obviously that's great as well. We'll have a chance afterwards to have a chat. There's still pizza, there's still free drinks, which is always helpful. But yeah, so welcome to Brighton Py. Okay, so tonight what we're going to be doing, we've obviously had some refreshments, had a little chat with a few people, and next what we're going to hear is a talk from Zac Nash, our very own Zac Nash from Datacove. You'll notice there are multiple Datacove people here tonight, or just the three of us, plus our lovely Zac, who's in Manchester and unfortunately couldn't make it because of the strikes. But yeah, he's going to be on screen, and he's going to be talking about unlocking the secrets of fish behavior using Python, which is an interesting title. So I'm quite interested. I haven't seen it yet, but I'm sure it's going to be wonderful. Obviously, none of this could happen if we didn't have the wonderful Silicon Brighton, and we've got Alex and Grace here tonight, which is absolutely fantastic. We also have Ronan from the Barclays lab. So actually, I'm going to introduce you, and he's going to do some housekeeping and let you know all about it.
Thank you very much. Hello. So welcome to the Brighton Eagle Lab. So for those of you who don't know, Eagle Lab is a national network of co-working and business incubators. So we are here to support businesses, educate, inspire, and kind of help them to grow and develop, really. So if anyone's got either a business idea or they're a startup, we kind of give them access to mentoring, funding, all those kind of things. And we also host really cool events like this one here. So really nice to have you all in the house. And if you've got any questions about Barclays Eagle Labs and how it might help your business or help your organization, then feel free to seek me out and ask me questions. Cool, and I'll pass you back. Oh, housekeeping, yeah, before I forget, the main reason why I came on. So yeah, basically, if there is a fire alarm, which we're not expecting one, we just out the front fire exit here, and then to the left is the Joker pub, and we just meet in front of the Joker pub, not inside the pub, just outside the pub. And then basically there is a toilet just on this level here, through on the right, and there is down the stairs on the left as well, toilets there as well. Okay, and then help yourself to drinks and pizza at the back. Awesome. There we go.
Thank you. That's great. I don't know, Grace, do you want to come and chat? Lovely. So we'll get Grace up.
Hi, everyone. Yeah, for those of you who don't know me, I'm Grace and I run Silicon Brighton. And if you don't know us and who we are and what we do, basically, this is not the only meetup in Brighton. It's not the only tech meetup in Brighton. It's not the only tech meetup run by Jeremy and Datacove team in Brighton even. There's loads of synergies across everything we do. But we actually support probably over 20 now altogether, covering lots of different skill sets, topics, big sort of themes that you can basically come to, like this one, for free, learn new stuff, meet new people, ask questions, explore challenges that you might have. But also if you're maybe thinking about getting involved, if you've got something that you would like to speak about, or if you'd like to get involved in some of the organisation of it as well, that's all like a really good thing to be a part of. And it's because of the people that are running it sort of day to day in their own time beyond their day job that keeps all of this cool stuff happening. So please get in touch if that might be something that you would like to do going forward. And do just check us out online to see what those other meetups are. Join our Slack group, or come and speak to me if you in some way would like to get involved. These are all our members. We're now funded by our membership, and we've got loads of cool companies. Datacove are on there as well. They're doing a lot of contribution, both financially and sort of day-to-day resource. But yeah, these are all our really cool members who fund the tech. Charlie over there sort of doing the AV, making this a live stream, so super inclusive. The beer, the pizza, as well as obviously the venue as well. So obviously a big thanks to Eagle Lab, and sorry about Fred. But yeah, so a big thanks to these people. And then a couple of specific call outs in terms of organisers that we're looking for. So PHP Sussex, so any PHP people. We have one organizer, but really keen to get a few more people involved. Same on the speaker side. And then we had Brighton Gophers as well, so Golang group that was running up until lockdown, had a few online, and it just sort of hasn't come back, but we're really keen to get that one back off the ground. So if you know any Golang people, if you are a Golang person, don't even know if that's the right phrase, but yeah, again, just get in touch with me. Specifically those ones we could really do with a bit of extra help with, and I think that is it. That is our events QR code. I didn't do these slides, you can tell, can't you? But these are some up and coming events. So we've got Async, which is tomorrow, Marketing Talk, which is happening on Friday lunchtime at Co-Marketing, and then PHP Sussex is happening next Wednesday. But that's our full calendar of events, and you can check that out on the website as well. And I think that is that. So yeah, that's everything. Thank you very much and enjoy the evening.
Thank you, Grace. Right, I think, is it over to Zac now? Yay.
Hello.
By the way, there we go. Here's our
You
Zac.
can hear me.
There he is.
Hi, everyone. Good evening.
Brilliant. And I'll hand it over.
Thank you very much, Laura. Well, good evening, everyone. Firstly, an apology. I'm sorry I can't be there in person. As Laura mentioned before, I'm in Manchester at the moment, so with the train strikes, unfortunately, I can't be there. I mean, I've heard that the numbers are really, really high as well for this event, so that's absolutely fantastic. I'd like to say that's because my face is on the banner for everything, but it's more likely all the work that Silicon Brighton are doing. They're amazing, and yeah, thank you for having me, of course. My first time at one of these events, so that's really exciting, but hopefully there'll be less strikes in the future and I'll be able to come down. But yeah, this is the talk. So unlocking the secrets of fish behavior using Python might be a strange title for someone doing data science at Datacove, but before that, I was a PhD researcher at Bangor University doing a computer science degree, which doesn't make it any clearer, really, does it? So firstly, we'll talk about the sponsors of this project. So KES2 is an organization that links companies and universities together with academic expertise to work collaboratively on research projects, basically. So if you're working towards a PhD or a master's, they can fund you and set you up with a company to take on sort of real world problems is the point. So I had two company partners, one being HR Wallingford and one being RS Aqua. So HR Wallingford are basically civil engineers who work on wave and flood prevention, and RS Aqua are marine science and technology distributors. So KES is funded by the ERDF, so they're a big part of it as well. And then CCAMS is an establishment within Bangor University which help with projects that support marine renewable energy schemes and that sort of thing. And of course, now working for Datacove, they don't technically sponsor or haven't sponsored any of the work that I've been doing on this, but they are sponsoring me to come here and talk to you all about it. And they've been really helpful with everything to do with it and giving me the time and space I needed to finish it. So I appreciate everything from them. But for the project background and aim, so the project came to be from a desire for a renewable energy developments package for Wales. So Colwyn Bay had a proposed tidal lagoon, which you may have heard of. It was also scrapped not that long ago, which you may have heard as well. But that didn't really affect what I was doing at the time. But also, if you've ever driven down the North Welsh coast, you'll have seen like a huge amount of wind turbines as well. So that's also a part of it. So the question is like, what kind of change does this have on the wildlife when you're making these huge, gigantic structures in the water and the surrounding areas? Because the whole point of it is to sort of be eco-friendly and sustainable when you're building these renewable energy sources. So what exactly is the effect of this having? And then when you try to look for this answer, you realize you don't even have the answer to a lot of the prerequisite questions. So we know life is there, obviously. We know that what fish are there, but we don't really know what that life does or where it migrates to or anything like that. There are really large gaps in knowledge for coastal waters. So the project aims really came about for these sort of overall goals, which are to fill these key knowledge gaps in understanding the fine scale movements of fish in these waters. And then from there, we'll be able to measure sort of the impact that these could have. And it could also sort of help when bidding for these kind of huge projects as well, because sustainability and environmental consciousness is a really big part of that platform. So another element of this is the fact that it's in academia, and because it's in academia, creating a low cost platform is a really big part of that. Especially if we want to use it on scale and we want multiple sort of vehicles and platforms, then we have to be working with low cost robotics. So it breaks down into these steps. So the first step is reviewing the current state of the art and science in the area. So that's in terms of robotics, it's in terms of surface versus underwater vehicles, it's in terms of how fish are tracked currently, and what sort of solutions there are already out there. We did this and we got it published as a state of the art review, and we got a good idea of sort of what's there, and the answer really is not that much, surprisingly. Step 2 is to purchase an off-the-shelf, in quotations, vehicle that can be modified to not require any human interaction. So that's essentially a boat or a torpedo-looking thing. Step 3 is complete these modifications to make it not need human interaction, but also to house any of the sensors that we need in order for it to complete the goals. And then step 4 is to develop the software to control that vehicle and track the targets, and also simultaneously localize and map SLAM the space. Finally, it's to show that the prototype works, essentially, in field trials. So as for current tracking technologies, I mean, you've probably heard of fish tracking or shark tracking or whale tracking. Well, how does that work? So traditionally, with like inland fish, you tag some of them with an acoustic tag, and then set up some like static sensor arrays like downriver, so that when the fish swims through the thing, you know that it's gone from A to B. For whales and sharks, the animals are still tagged, but like a man team on a boat follows that around, which can take a huge amount of resources, monetarily and time and manpower. But if you're anything like me when hearing about how little we know about these whales, where they go for most of the year, because apparently we don't know that, because we've seen footage of them tracking them. Well, where do they go for all this time? And that's the reason why we don't really know, is because of how much resources it takes to track these things. So this is where we get to the idea of an autonomous system. So like what improvements can be made on the current state of the art, and how can we use technology to improve on these systems? So, I mean, like seemingly everything these days, we have to try our hand at some autonomy. This way we don't need static arrays. We don't need a huge amount of resources and manpower following whales around forever. And we can sort of use these dynamic arrays and follow them around without any manned missions. So for vehicles, we had 2 options. Well, we had 3 options, but we've got 2 here, which I'll get onto in a second. But we have 2 options. So the first is H.R. Wallingford's Ark boat. So this is a surface vehicle. doesn't cost that much, but I mean, relatively speaking, obviously. But if you remember from the second slide, they are a project partner, so we kind of got this one for free. But it's essentially just a really large remote controlled boat, like you see children play with at lakes, but on a much more expensive and larger scale. And it's got like a lot of housing there for like a huge amount of sensors. So you can see some of the sort of overview here, where you can see the navigation is radio controlled. There's dual props on the back. It's a very simplistic design. And HR Wallingford are based, unsurprisingly, in Wallingford. So they're relatively local, I guess. But yeah, I mean, it is when it comes down to it, it really is only a remote control boat, and it's not really designed for this purpose, but it is simplistic and durable. So simplistic and durable, but would need a lot of development. The second one is the more fancy package. It's an underwater vehicle that looks more like a weapon or a torpedo than it does a research vessel. This is the Riptide. So the Riptide is a lot more expensive. It's also based in the US, but it is an underwater vehicle, and that's kind of cool. So yeah, I mean, you have the 3D movement, obviously, because it can go underwater. It's not just traveling over the surface. It has a huge amount of sensors, and it's pretty much almost there out of the box. So there's behaviors that are developed into that, like loitering and going in circles and returning to home base and surfacing and that kind of thing. So I'm already there, but because of the sheer amount of sensors and there's the vehicle itself, it's extremely complex. So it's difficult to fix anything that's wrong. And that was quite apparent. So I personally wanted to build my own vehicle, and that's sort of the nature of ambition, I guess. But that got rejected. And despite sort of my best arguments, we ended up going with the more expensive package, so the Riptide. I mean, maybe mine wouldn't have been as good. I don't really know much about building boats. I don't really know much about fish, but here we are. But you know, what mine wouldn't have done is catch on fire the second time we turned it on, which this one did. So I mean, I wasn't there when it happened, so I didn't have to be the one that explained this to the university, that the brand new fancy torpedo toy just, went up in flames. So that's good for me, I guess, but not good for the project. But I mean, the bigger issue with this is that they're not UK based. It took months to ship it here, and it was shipped in like a military crate, and it took a long time to send back. And if that wasn't enough, if anyone has got like really good eyesight, probably not on that tiny screen, but above the Riptide logo there, you can see BAE Systems, the famous like worldwide defense contractor, next to the little warship. Now, defense contractors are very difficult to get support from anyway, but even more so when they just acquired the company you want to talk to. They acquired them 2 weeks after it set on fire, so that was pretty much a dead end, to be honest with you. So, unsurprisingly, here we are, back to the Arc boat. So, I mean, I was staring at the simplistic and durable, specifically the durable part, and hoping with the best intentions that this one doesn't set on fire as well. So here's some like really simplistic designs of what needed to be achieved. My focus were on the last three here. I sort of left the first one to the marine biologists. I can't really say I'm too enthusiastic about opening up fish while they're alive and putting tags into them. So I left that to the marine biologists. But the rest of it was my work to do. So that's acoustic development. So signals being picked up on these hydrophones here and then being processed with that Orca board. We'll get more into the detail on the hardware later. But we also have the vehicle development, so housing all this stuff and making it work with the boat itself, and then the software development, so the actual processing of this into useful information. tracking behaviors, and then all the other stuff that comes on top of that, like control systems and logging and emergencies and stuff like that. So as for the acoustic development stuff, we had to figure out how many hydrophones we need and how they'll be used. So we did some experiments because, like I've said there, the design had to reflect the drawbacks of using a surface vehicle. We no longer had access to the 3D plane. So the experiment showed that the lower in the water, the better, which isn't really too much of a surprise. And neither is the other one, that the further away the hydrophones are from each other, the more accurate the triangulation. The experiments also showed that the more hydrophones, the better, really. But it's still possible with 2, which is not very good. So we went with 3, and that you can sort of see with the drawings of how they'll be housed on the vehicle, and then finally with it actually in the water, how it looks with that structure on. Now, before going to the next slide, a question for everyone, for my own personal interest. I'm going to ask you some languages. What's the first programming language that comes to mind when you think of robotics? So are we good to give the microphone to Jeremy, and so I can actually hear him, because currently I can't hear him.
Yeah, I'm here.
So
God.
So I mean, how many beers deep are we, Jeremy? Are we good to go?
Only about 15 at the moment. You should be all right.
All right, we're fine. We're fine. You can see far enough. Okay, so
It's
I'm
about
gonna
500 people here. Yeah.
500 or 600, give or take.
Yeah, roughly.
Okay, so I'm gonna name some programming languages. What's the first one that comes to mind when you think of robotics? So I'm gonna do this one for Jeremy's sake, because he's a bully.
What?
R. Can you raise your hand if you thought of R? Is that? I mean, I can.
400.
Did anyone put their hand up apart from you, Jeremy?
No.
Right. Okay. I feel like the next one might be slightly leading, given the conference we're at, but Python.
1, 2. I'll go with about 2.5.
Right. Half a hand. Okay. Java.
It's got less than R.
So no one. What about C#?
Oh, is that a half or a quarter or
Quarter of a hand.
The hand was sort of going up.
Okay, but not quite there. Okay, and C or C++?
Whoa. Oh God, I really have had too many beers. I'm not going to count that. Like
More.
about 80% of the audience.
Right, that's unsurprising. Okay, thank you very much, Jeremy. It's pretty much what you would expect, I would think.
Can I sit down now, yeah? And turn the mic off?
Yeah, you're more than welcome to sit down. Wobble back to your chair. All right, thank you very much, Jeremy. So yeah, I mean, pretty much exactly what I thought. I thought Java would get 1 maybe because of AlphaGo and IBM's Watson. C# is part of the Microsoft Developer Studio platform, and I guess Unity as well if you're into game development. But yeah, I mean, C# and C is quite famous for robotics. Pretty much everything in robotics is developed with C, by C, or with C in mind. So yeah, the whole low-level hardware interaction, the real-time formants, all that stuff is fairly known. But Python is seeing a slight emergence with it, and that's more than likely because of its AI tools. Obviously, with data science, Python's a pretty strong contender when it comes to AI and machine learning, and with robotics, with things like SLAM, packages like that are desperately needed, especially when it comes to like object detection and avoidance, that kind of thing. So we have C and we have C++. Most of the time we have Python. Now, C++ has access to Moose and ROS. which are two platforms we'll go into a little bit later. Whereas Python has access to just ROS, essentially. So ROS, if you don't know, it's an open source middleware platform. There's a little bit on there if you want to learn a bit more. They always have these weird names for the update. So this one's Humble Hawksbill, but it's always an alliteration, an animal of some kind for each update that comes. But there's a bunch of stuff on there, but the main thing that we want from this is the idea of multi-domain and multi-platform. So we know that embedded systems are going to be a big part of this. We can't stick a computer on the boat. So, well, a big computer, like a personal computer, obviously we'll be putting a computer on it somewhere. But we'll need it to run code and interface with some of the sensors. So the idea of it being multi-platform and multi-domain is really important. The other aspects are it's proven in use. I mean, this stuff, the ROS is used worldwide and has a huge amount of projects, both small and large. It's hobbyist, but it's also in parts of it, I think, are in the Mars rover and stuff like that. Also, the global community. So it's huge and the support is there from its community, and that's super helpful. Everyone who's worked with packages in R knows the power of that community. And the same goes for Python. The next is Moose. So Moose is really marine specific, and it's found on that Riptide vehicle. I had the pleasure of going to MIT to a Moose conference and watched a lot of their marine vehicles using it. It was super impressive. They'll have a lot of sort of built-in applications for marine vehicles, which would help massively. So, the idea of mission monitoring, safe deployment, that kind of thing, mission analysis, it's all with marine developments in mind. It has a ton of off the shelf, I guess you could say, behaviors in there, and it's been tested on a bunch of different platforms as well. But I mean, as we mentioned earlier, ROS and Moose both use C++, and just ROS uses Python. So, I mean, it's kind of a spoiler alert that I'm talking at this event, isn't it? But it's fairly obvious which one we went with. ROS. So, ROS, for anyone who doesn't know, is pretty much simply put a communications network. So here you have the nodes, and you have publishers, and they send messages to a topic, and people and nodes that are subscribed to that topic receive that message. It's all about hardware abstraction, low-level device control, and implementation of commonly used functionality. So it is literally just message passing between processes. But because of that sort of global community, it also has a lot of inbuilt packages for different embedded systems, like a Raspberry Pi or a BeagleBone. So for what we've had to develop, this is what we've had to develop. So we started by developing some simulations in NetLogo. If you've ever heard of that, that's in Java. So this is for the AI behaviors we wish to see. So that's things like following the track target, loitering, don't get too close to the track target because they fish and they run away, and you can't exactly study their behaviors if you're just chasing them away from the shores. And returning to base, that sort of thing. And we want to see how effective these are when you change fish speed. Now, we did end up, as I think I mentioned in one of the other slides, chasing cat sharks. Now, that's less of a chase and more so just standing there watching it because they're super lethargic. But that's just a proof of concept. So we didn't have to push the limits too far. But obviously, tides are a big part of it, especially on a surface vehicle. Embedded system development, multiple sensor usage, all those kind of things are part of the embedded systems. Open source acoustic processing packages. So that's to take all the hydrophone data, which hydrophones, if you don't know, are just an underwater microphone to pick up acoustic signals. So processing that from raw data into an actually usable format. Localization and mapping, and that works with integration with Mavlink protocols. Mavlink, if you don't know, is a set of protocols for communicating over Wi-Fi for autonomous vehicles. So it's all about where is my vehicle and how do I control it. Logging, that's a big part of robotics, obviously. What went wrong and how can we do it differently next time? But also a part of ROS is it saves every detail of the mission, every signal it gets, every topic it publishes. So you can basically do one experiment and run it as many times as you want. Emergency states, so that if something sets on fire again, it does the right thing. Vehicle control, and connection between AI and acoustic processing. So that's all about the control systems and how do we control the motors, and then connecting that to the AI, and then furthermore the acoustic processing. So how do we take the acoustic processing, which gives us like a heading and a distance, and then take that for it to infer behaviors. So if it's too far away, we should probably speed up. If it goes left, we should go left, etc., etc. And that's part of the AI behaviors. And then finally, the connectivity with the vehicle. So if you remember on what sort of networking the boat had on it originally, it's none. It was literally just a remote control boat. You can't do a huge amount with that. So here's how it all looks in code. So, you know, an academic. So academia love their UML diagrams. So here we go. If you have incredible eyesight, you might be able to read this. I'm realizing now. But essentially we have multiple ROS servers and multiple ROS clients. So a ROS server holds the functionality and the ROS client calls that functionality. So the process is to stream data at a rate that matches the frequency of the tag that's in the fish, so you can hear it, and then send that information, publish that information to the processing server. That's then called, and that turns things into a localization. So then from there you can get heading and distance, and that you do that using triangulation. So where is it in relation to the 3 hydrophones we have, and how long did it take to get? If it took less time to get to the left one than it did to the right, then you know it's on the left, that sort of thing. So this is all information that's needed to infer behaviors. Yeah. So as for hardware integration, now, like I said, I'm a computer scientist, right? So that was my background. That's what I did my undergrad in. I'm no electronic engineer, but I had to become one, and a marine biologist and everything else to do this sort of stuff. So here we are. How do we make our boat do this? Well, as it stands, it's just a radio controlled boat. So we can work with the motor controller, and that's found just below that panel there. And what we do is we emulate those radio signals. This wasn't easy. The documentation for Chinese radio receivers that are about £3 on eBay are not the best. So it's a lot of time spent reading signals on things like an oscilloscope, so that the boat didn't share the same fiery fate as the previous vehicle. But yeah, so how do we send those signals? How do we connect up the hydrophones to all this? How do we make sure it doesn't hit a wave and get dismantled? So from all that, we have our autonomy box. So the autonomy box houses a bunch of development boards, a bunch of processing boards, and a bunch of receivers and senders. So we have the support for the hydrophones. We have the motor controller connectors, which go into the boat. We have Wi-Fi, an IMU, barometers, remote control for both radio and Bluetooth. So as part of one of those emergency states, we can take over using the original system. But ideally, we want to be using Wi-Fi or something like that to control the boat. So inside the box, we've got these 2 Linux-based development boards. Raspberry Pis you've almost definitely heard of, and that's for the autonomy and the acoustic processing. But Pis aren't the best for input-output controls. So that's where the BeagleBone Blue comes in. Now, you've probably not heard of the BeagleBone Blue, I'd be surprised. But essentially what that does for us is it takes the inputs of all these sensors. So It has an IMU built in, but it has the PWM outputs that go to the motor controller to control the propellers. It has the GPS, has the IMU, and connectivity to the radio controller, the remote controller, sorry. And then finally, RS Aqua, they supplied the hydrophones, and they also supplied a board to stream from those hydrophones. So that's what that's for. It's pulling the data from these hydrophones into the boards. And this is what it kind of looks like. So, I mean, you saw it a little bit here, but without all my messy attempt at soldering and wiring, it's here. So we have multiple boards connected to a multitude of sensors, all wired up differently by different connection types using different standards, and somehow it actually works. So this is what it looks like from ground base. So that when you're at the side of the water, this is what it looks like. So we're using Mission Planner. We can implement our missions, our behaviors. We can do things like surveys, like you see on the left, and you can add dynamic waypoints, which you can see on the right. So like, hey, there's a fish 40 meters that way, let's go in that direction or whatever. The mission will dynamically update the waypoints as it goes along. And if you have any interest at all, this is what it looks like for the boat. You should be able to see it here. So this is what it looks like for the boat, or also a drone on the top of the boat, above the boat even. So this is what it looks like on a very, very cold but picturesque day in Snowdonia, Clynpaddan, near Llanberis. And then you can see all of HR Wallingford's video. Sorry about that. But yeah, that's what it looks like in action. But that's everything from me. So thank you very much. All our contact details are there. I'm sure you know of Datacove by now. You've all met Jeremy and stuff. So our email's on there. But also, if you have any interest in any of the other stuff, RS Aqua and HR Wallingford's contact details are there. Thank you very much. And any questions, of course.
That was awesome. Thank you, Zac. Obviously, I work with Zac on a day-to-day basis. I think he's a great guy. He's very helpful and supportive. He's also really smart. I mean, I knew that, but wow, I really think you're super smart now. Good job. So yeah, and has anyone got any questions? Yeah.
Hello.
Hello.
Shall I look at you? Hey.
if possible, that would be fantastic. I mean, you're still a tiny square on my screen, but we're working with it.
Cool. Yeah, so I've actually used Ross a lot before. My first job was with Ross. I just wanted to ask how you found it. And also the proper question is, with an environment as complicated as the sea, what sort of measures did the team take to minimize the disruption that the boat would make, or what considerations were there for that?
Brilliant questions. Firstly, with Ross, it was certainly difficult, I felt, at the start. You know, I had no experience with robotics. I mean, I keep saying I've got no experience in anything, but I had no experience in robotics or Ross before it, so it was one hell of a learning curve, I think, personally. Moose, if you've never worked with that, is like almost identical in terms of like how it works and how you get things running. But I personally found it difficult. I'd be interested to know how you found it, given that you worked in that, and also how the hell you got a job in robotics. Because there don't seem to be any of them. Not that I don't absolutely love what I do now, by the way. I can see you laughing, Jeremy. And for I mean, that was definitely a part of how we planned the missions. So firstly, we had like a ton of support vehicles. So CCAMs that I mentioned definitely was a part of supplying like safety boats and stuff, and also it made it really a point of anxiety for me, because I don't know if you saw in that last video, there's there's paddle boarders in the area. So I don't want my robot to go killing someone and it suddenly zooms off in a direction you don't expect it to go zooming. So safety was sort of like, and risk assessment as well as always a part of academia, but that was always a huge consideration. So going very slowly was basically the way that I did it. But also that boat in particular, so the underwater vehicles would have been better for like tides and stuff, but the surface vehicle, HR Wallingford is huge, and they've got these huge wave simulation things. It has like these mechanical plates that simulate waves for flooding. So they like build out towns in South Africa or whatever, and then you can see how it would affect it with these plates. So that boat specifically is really well tested when it comes to waves, more so than any other of the same type, I would say. So we were pretty confident and comfortable with it being able to deal with tides and stuff like that. But obviously, as a general rule of thumb, don't go out when the North Sea is crazy. Thank you for your question. I do want to hear about your Ross experience.
Oh, there's a follow-up here.
Hey again. Yeah, so I did a couple of internships at uni. That's how I got into Ross. And I think the primary reason that they were using Python is because they're not primarily software developers. They're interested in robotics and the kinematics and all that stuff. So they just want to do something that works, which is fine.
Yeah.
Until you're working with someone else's code, and then it's not fine at all.
Yeah, for sure. And it also comes to that you want to see something working. And if you're using C++, like that can take a long time to see things actually working. Whereas Python's so good at, you can just write something and just watch something move. And that's the coolest part of robotics is like seeing the real world application of what you're doing. So if you can get that done quicker, then that's super ideal.
Awesome. Anyone else? Yeah.
Hi, Zach.
Hello.
Hi. Yeah, we only ask questions if we're in view. I was just wondering, how do you know how close to follow the fish that you're not disturbing it?
It's a good question. The answer is I ask the marine biologists and hope they don't lie. They present me with some papers and stuff, but I don't think it's really conclusive. I don't know. I can't imagine anyone's like throwing rocks into the ocean and seeing how close they can throw it to the fish before it scatters away. So there isn't a ton of information on that. So as a general rule of thumb, listen to the people that know more than you and hope they're telling the truth. That was my way of going about it anyway.
Hiya. You're talking about a lot of different protocols, Wi-Fi, Bluetooth, radio, I assume like 27 megahertz or something like that for like radio controlled car world. That seems like a lot of different RFE things that you're just sort of using locally on the boat, which surely was a big power issue and stuff. Why didn't you just solder wires?
Why didn't I solder wires?
As opposed to using, RFE solutions it seems like you were using a lot of, radio-based solutions to move data around the boat. Or am I missing a point there?
Yeah, I think what it is the communication for like Ross and things like that. We were just using sort of like Ethernet cables between the devices. The radio itself, all that was for the emergency protocols, so like the actual radio remote controller, so that could take over in the event of anything going wrong. PWM, that was soldered into the motor controller. Bluetooth, we really didn't get any use out of, if I'm honest. It was just there for updating the software and stuff if we wanted it to do that. But generally, when we're doing that kind of process, it was out of the water anyway. So really the main things were Wi-Fi to communicate with the vehicle, and the internal communications over sort of like Ethernet or USB. Oh no, not Jeremy.
Hey,
Hello.
that was a great presentation. Yeah, I was just interested to know how long it took you to get from kind of like the planning to the final kind of like product. I don't know if you had already mentioned that. I might have just missed it.
No. Thank you for your question. Too long. So it was made longer by COVID and stuff like that. Unfortunately, you can't during a lockdown, you can't get a team of like 10 people in a support boat to take a giant boat to a lake and then I'll get on the boat together and watch it go. So that was definitely made longer, but it in actual time, it was about 3.5 years going from like coming on board. But there was a lot of time before that, before I came on board, that was like acquiring grants and putting through proposals and that kind of thing. You know, like the initial steps to getting these kind of sponsorships. That was, I think, 2 years in the working. So it's an culmination of like a lot of work and effort from quite a few people and a big project team of like 5. But obviously, you know, when it comes to like the engineering and the computer science stuff, that was my work, and that took from design about 3.5 to 4 years.
Thank you.
Of course, you've got a question from Jeremy.
Thank you. I'm very excited.
Did you honestly expect I wouldn't ask a question?
No, I knew. I deserve it for last time you were talking. I get it.
Exactly why. Very good talk. Obviously, you should have done it in R, but never mind. So you made me do all this wonderful counting, and C++ came up as the language that everybody would use. So why Python?
The honest answer is because C++ terrified me at the time. I'd done a little bit of work in Python before, so I jumped at the possibility of using Python over C++. That was any excuse. But the reason I wrote down was because we could prototype something far quicker in Python than I could in C++. That was the answer that I wrote down. The real one was C++ is terrifying, and I don't want to learn it.
Fair enough. Next time in R.
Yeah. Thank you for that, Jeremy.
Yeah, you want to add to that?
Hello, just to respond to you, Jez. I've written in both C++ and Python for robotics, and I use C++ for huge projects and Python for a smaller project. And the difference is just night and day in how fast you can get stuff done and how people who are not, professional software developers can contribute to that. But yeah, anyway, I'll stop.
No. It's a good point. So you personally would recommend Python over C++? Is that what you're saying? Right. Yeah. Do you want to come tell my professor that in my Viva, and that might win me a few points? Thank you very much.
Thank you, Zach. That was incredible. I hope you all enjoyed it. I didn't know if you heard a lot of tittering going on, a lot of giggles. So thank you very much for that. Really
no, I'm completely muted. I was completely muted. If any jokes landed, I have no idea. But there we go.
Yeah, well done. You can watch it back again and see.
Sounds like my nightmare. No, I don't think that's going to happen.
No, maybe not. But yeah, we want to thank everyone. Obviously, everyone online who couldn't make it in person today. Thank you so much, and I hope you really enjoyed it. So yeah.
Thank you very much, everyone.